It's chemistry time. We are looking at the topic molar volume, atomicity, and vapor density. Now, the molar volume of a gas is the volume occupied by 1 mole of the gas at standard temperature and pressure, while the atomicity of a gas is the number of atoms contained in 1 molecule of the gas. And finally, vapor density is the number of times any known volume of a gas is as heavy as an equal volume of hydrogen at the same temperature and pressure. The molar volume is the volume occupied by 1 mole of any gas at STP. STP means standard temperature and pressure. That is, 1 mole of carbon dioxide weighs 44 grams and occupies 2.4 dm³. This is applicable to all gases. 2. Atomicity of an element is the number of atoms contained in 1 molecule of the element. We have some monoatomic, if the molecule contains 1 atom like helium, diatomic if it contains 2 atoms like oxygen, and polyatomic if it contains 4 atoms like phosphorus, so on and so forth. Let's consider the term vapor density. It is the number of times any known volume of a gas or vapor is as heavy as an equal volume of hydrogen at the same temperature and pressure. Let's consider an illustrative example. This example is under molar volume. It reads, at STP, how many liters of hydrogen can be obtained from the reaction of 500 cm³ of 0.5 molar H2SO4 with excess zinc metal? Ground molecular volume of hydrogen is 22.4 dm³. The options are A, 5.6 dm³, B, 0.56 dm³, C, 0.65 dm³, and D, 6.5 dm³. Now, from the statement 500 cm³ of 0.5 mole H2SO4, it simply means that 1000 cm³ of H2SO4 contains 0.5 mole. Therefore, we're given 500 cm³ of this is equal to 0.5 over 1000 times 500 over 1. 500 over 1, 502, that is 0.25 mole. That is to say, the number of moles of H2SO4 is 0.25. Now, let's consider the equation of reaction. Zinc plus H2SO4 gives zinc tetraoxide 6 plus hydrogen. The equation is balanced. And so, when you have 0.25 mole of zinc, since it is a one-to-one relationship, it also implies that the number of moles of hydrogen is 0.25 mole. But we know that 1 mole of any gas, hydrogen is a gas, that 1 mole of any gas at STP occupies 22.4 dm³. That is, 1 mole of H2 at STP occupies 22.4 dm³. Therefore, we have 0.25 moles. Therefore, 0.25 moles hydrogen at STP occupies 22.4 times 0.25. That gives us 5.6. From the solution, the volume of liters of hydrogen obtained is 5.6 decimeter cube. Take note, decimeter cube is same thing as liters. And consequently, the correct answer is 5.6 dm³. Second illustrative example. What volume of oxygen is produced from the decomposition of 2 moles of potassium triazochloride 5 at STP, given that the molar volume of a gas at STP is 2.4 dm³? The options are A. 0.672 dm³, B. 60.2 dm³, C. 67.2 dm³, and D. 6.72 dm³. Let's consider the equation of the reaction. KClO3 similar to KCl plus O2. Balance equation 3, 2, 2. From this balanced equation, 2 moles of potassium triazochloride 5 has produced 3 moles of oxygen. 2 moles of potassium triazochloride 5 has produced 3 moles of oxygen. But we have earlier said that 1 mole of any gas at STP occupies 22.4 dm³. 1 mole of O2 at STP occupies 22.4 dm³. Therefore, 3 moles of oxygen at STP occupies 22.4 times 3. 12 to carry 1, 6, 7, 6 dm³. From the solution obtained on the board, the volume of oxygen is 67.2 dm³, and consequently the correct option is C. Let's consider the third illustrative example. It reads, consider the reaction represented by the equation. 2 sodium hydrogen triazocarbonate 4 is heated and gave us 2 molecules of sodium triazocarbonate 4 and carbon 4 oxide and water. What volume of carbon 4 oxide at STP is evolved when 0.5 mole of sodium hydrogen triazocarbonate 4 is heated by giving the molar volume at STP to 22.4 dm³? The options are A. 5.60 decimeter cube, B. 0.056 dm³, C. 0.56 dm³, and D. 5.6 dm³. Now, from the balanced equation, 2 moles of NaHCO3 produce 1 mole of CO2, but we are given 0.5 mole. 0.5 mole of this equivalent to 1 over 2 times 0.5 over 1. That is 0.25 mole. Now we are familiar with the fact that 1 mole of any gas, that of CO2 at STP, occupies 22.4 dm³. Therefore, 0.25 mole of CO2 at STP will not be equal to 0.25 multiplied by 22.4. That equals 5.6 dm³. Well, from the solution to the problem, the volume of the gas is 5.6 dm³. And turning to the options, the correct one is D. Let's consider the fourth illustrative example. An element X forms a volatile hydride, XH3, with a vapor density of 17.0. What is the relative atomic mass of X? Now the options are A. 31, B. 30, C. 32, and D. 33. I want us to recall that relative molecular mass is 2 times vapor density. Now, in this problem, we're given that the vapor density is 17. And so the relative molecular mass is 2 times 17, which is 34. Now, the hydrogen we are given is X plus 3, and the mass of this is now 34. Now, we know that hydrogen is 1. So that's X plus 3 into 1 is equal to 34. X plus 3 is equal to 34, and X is 34 minus 3, and X is equal to 21. Now, from the explanation on the board, X is 31, and consequently, the correct option is A. 5. Determine the vapor density of sulfur 4 oxide, given that the relative atomic mass of sulfur is 32 and oxygen is 16. The options are A 30, B 35, C 32, and D 22. We've earlier said that relative molecular mass is 2 multiplied by vapor density. So when we determine the molar mass of SO2, molar mass of SO2 is 32 plus 2 times 16. 32 plus 32, that's 64. So relative molecular mass, we said is twice vapor density. So 64 is 2 multiplied by vapor density. Therefore, vapor density is 64 divided by 2, which is 32. For the solution to the problem, the vapor density is 32, and so the correct option is C. Example 6. 56.0 cm³ of a gas at STP weighs 0.11 grams. What is the vapor density of the gas? The options are A 22, B 33, C 44, and D 11. Solution is worth remembering that 1 mole of any gas at STP occupies 22.4 dm³. That is 22.4 dm³ of a gas at STP with 1 mole. 560 cm³ of gas weighs 0.11 grams. So the molar mass will be the mass of 22400 cm³ of gas. It's equal to 0.11 divided by 56 times 22400 over 1. And this gives us 44. So this is the molar mass. Therefore, vapor density is relative molecular mass over 2. 44 over 2, that is 22. From the explanation on the board, the vapor density is 22. And consequently, the correct option is A. The last but not the least example, 7. Calculate the vapor density of a triatomic gas X if its relative atomic mass is 16. The options are A 24, B 26, C 28, and D 22. Now, the gas is said to be triatomic, and so X3, and we are told that the atomic mass of X is 16. And so 16 times 3, that's 48. So molar mass of X is equal to 48. But molar mass is equal to 2 times vapor density. So 48 is 2 times vapor density. And so vapor density is 48 divided by 2, which is 24. From the explanation given above, the correct option is A, 24.